Hey everyone, it's Colin. How's it going? You probably know one of my interests is in retro audio equipment, and while I've done videos about a decent variety of it, there's one format I've wanted to check out for a while now. I picked up a Philips DCC 900, one of the first digital compact cassette deck models ever made. DCC was a format that could, like its name implies, record digital audio onto cassette tapes, but it could play back analog cassettes too. This unit was being sold for parts or repair with the problem description that it would try to play tapes, but there was no audio. It arrived in good shape, though it was pretty dirty. Looks like it may have been stored in a garage or something for a while. Based on its serial number, it was manufactured in 1992, which means it's from early in the production run. DCC as a whole was introduced in the fall of that year with the 900 as a launch model. It powered on just fine, and indeed, when I dropped in a cassette, the only audio was an intermittent clicking noise. I could tell the tape was definitely moving in the mechanism, so it likely wasn't a problem with belts. So I decided to pop the cover to see what else could be wrong. Some research suggested I check out two specific circuit boards. The first is underneath this metal bracket. It slots into a card edge connector on the main board and has a flat flex cable going into one end. This is the board that primarily handles digital audio, and these capacitors have the tendency to go bad. The other PCB was a bit more involved to get at. I had to remove the screws holding on the front panel. There's a few across the top and then two more down in the bottom corners. I didn't have to take it off completely, just pop it forward a bit. I noticed a loose surface mount cap rattling around in the bottom of the deck, along with this spot of leakage on the side of the tape mechanism. That's not good. A few cable harnesses needed to be disconnected from the other side of the mechanism, then I could take out 4 more screws and lift the entire thing out of the chassis. The PCB I needed to check out is attached to the back of the mechanism. I was surprised to see that the belts on the side were still in reasonably good shape. These handle opening and closing the drawer the tape sits in. And looking at the bottom, the main drive belt seemed to be good too. But what wasn't so good was what happened when I went to remove the single screw holding in the PCB I was after. I literally just touched the other side of the board and this cap fell off. I disconnected the flat flex that went up to the tape head and flipped the board over to find really bad news. The capacitor leakage was pretty severe. This is called the read-write board, and I started by cleaning it with an IPA wipe. You just touch them and they fall off. Interestingly, it's generally just the polarized caps that tend to fail. This board has 2 non-polar caps that look just fine. There's a spot where it looks like a cap is missing, but this is normal. These pads ended up going unused in the design, so the factory never put one here to begin with. To reduce the risk of further damage, I covered some of the components with Kapton tape, then used my hot air rework station to gently remove the remaining caps. The leakage wasn't nearly as bad on the digital board, but I used hot air to remove its caps too. Between some fresh solder and desoldering braid, its pads cleaned up well and seemed mostly intact. This board shouldn't be too much of a problem to get working again. But that read-write board was another story. Its caps caused far more damage. Many of the pads were outright gone. The electrolyte inside capacitors is very corrosive, and seeing traces on PCBs that have been eaten away by it is sadly becoming common with retro electronics. I felt that repairing this level of damage was beyond my skill level, so I got in touch with perhaps the best resource for getting it fixed: the DCC Museum based in California. In addition to hosting a large collection of DCC equipment and media, they also offer repair services, and were happy to take a look at the board for me. Due to how the DCC technology works, it's best to keep the tape head and its read-write board together, so I packed up the whole tape mechanism and shipped it off. While I was waiting for the package to get delivered, I got new surface mount caps installed on the digital board. Thankfully, none of the other caps in the deck seemed to be affected. Aside from some dust, the main board looked just fine. And that's a good thing because I'd hate to have to recap this one. After the package arrived at the DCC museum, I got bad news. The box had apparently been beat up in shipping, and the tape mechanism itself took some damage. I thought I had packed it well, but rough handling and 30-year-old brittle plastic was apparently too much. What's worse was what I found out about the read-write board. After going through an ultrasonic cleaning, it was deemed to have too much damage to be feasible to fix. When I got the box back, I was definitely feeling bad about how the mechanism had gotten wrecked. I thought I had done the right thing by acknowledging the limits of my own skills and sending it to someone who was better suited to fix it. But taking a look at the PCB strangely made me feel a little better. Many traces and vias on the board were outright gone, and if repairing it was possible, it would take hours of precise microsoldering under a microscope. In comparison, the broken mechanism was no big deal. And that's because spare parts for these decks are pretty much non-existent now. I can't just jump online and buy a new read-write board, so with mine more or less unrepairable, it doesn't really matter that the mechanism is trash too. The whole deck is now just a parts unit. So I bought another one. This DCC 900 was being sold by someone who had picked it up a few years prior with the intention of restoring it, but never got around to it and lost interest. They even threw in the new capacitors and belts they had planned to install. It was also a complete unit, including the remote control and the user manual, and overall looked to be in better condition than the first deck I had bought. It was a lot cleaner. Clearly it was stored indoors, and the only thing cosmetically wrong with it was a dent on the top cover. This is pretty common with stereo components anyway. Since I knew it needed new caps, I went straight to taking it apart. When I popped the cover, I noticed that the cable harnesses going to the tape mechanism had already been disconnected, so clearly I wasn't the first person in here. When I pulled out the digital board, I saw that its flat flex cable hadn't been reconnected fully either. It's always a risk taking on someone else's project, and I was starting to get a bad feeling. But with the relative scarcity of these DCC decks, I didn't have many options. The deck wasn't missing any parts and nothing inside was broken, so the rest of the disassembly was uneventful. Just like on the first deck, these belts were still surprisingly intact, though I planned on replacing them anyway. And flipping the tape mechanism over, it looked like the read-write board had gotten checked out at some point, and somewhat hastily reassembled. I got it removed from its bracket, and thankfully it looked to be in way better shape than the first one. All of the caps were still there, and there were fewer signs of leakage. But in the very least, this PCB would still need a solid cleaning in addition to new caps. I started with the digital board, removing the old caps with hot air as before. There were few signs of damage, so not only were the solder pads and traces in good shape, they cleaned up very well. The new caps included with the deck were high-quality Nichicon parts, and I decided to use them because they were through-hole instead of SMD. Electrically, there's no difference, and while they look kinda ugly, tacking down through-hole caps to surface mount pads is quicker than installing SMD parts. And since it's quicker, it means less time is spent with the soldering iron heating up the pad, which in turn means less risk of lifting one that's weak. Onto the read-write board. I cleaned the back side with an alcohol wipe because I found some signs of electrolyte leakage and minor damage there too. There was no drama removing the old caps, and the damage definitely looked to be less severe than the board from the first deck. I got it wiped down and tidied up the solder pads. There's a few spots where it looks like traces got damaged, but I tested for continuity and everything seemed to check out. And because all of the pads were intact, it was straightforward to get new caps on this board too. I tackled the belts next. There are two on the side for the drawer mechanism, and after removing them, they definitely reflected their age. The rubber had hardened and they were no longer stretchy. The new ones went on easily, and I turned my attention to the main belt. I needed to clip this zip tie holding some of the wiring, then I could disconnect two cable harnesses and a ribbon going to the side PCB. I flipped the mechanism upside down and took out the 4 screws holding in the motor assembly. Then I could lift it out and the old belt came with it. I got the new one routed around the flywheels, then hooked it to this screw standoff. The next part was tricky. I needed to put the motor assembly back in, then get the belt off the standoff and around the drive pulley. There's not much room to work, and even less room to see what you're doing, but eventually I got it. Time to reassemble the deck after all that repair work. I was really hopeful that after the relative disaster the first deck turned into, this one would work out much better, and so far, that appeared to be the case. While the previous owner had definitely poked around inside, that seems to be all they did. I felt like I dodged a bullet by not inheriting someone else's failed project. I dropped in a test tape and was glad to see that the new belts were working properly. But when I went to play it, yeah, it had the same problem as the first deck. No audio at all. The tape was definitely moving and the head was making contact, but nothing. Why do you do this to me? I had read that sometimes the problem only affects either analog or digital tape playback, so I tested again with a DCC tape I had picked up. The deck knew it was a digital tape, but still didn't play any audio. While I figured out what to do next, I took the deck apart again and soaked the 2 PCBs in isopropyl alcohol. If there was any contamination I had missed earlier, this would hopefully take care of it. I went through the service manual and found that the DCC 900 has some built-in diagnostic capabilities. I reassembled mine and entered service mode by holding down play and stop while powering it on. I cycled past the display test option, then started playing a DCC tape and took a look at the error rates it was coming back with. They were terrible, basically indicating that the deck wasn't able to read anything off the tape. This could have been due to the read-write board, but it also could have been a problem with the tape head itself. The heads used in DCC decks are not like normal tape heads, and apparently are not just susceptible to getting dirty, but are also prone to failure. So that's the path I went down next. I did notice that the head in my deck was a little dirty. Nothing horrible, but even after gently cleaning it, the problem was still there, as I kinda expected. It's possible to test one of these heads on its own, but to do that, it has to be removed from the tape mechanism. I found that taking out the right pinch roller assembly made this a lot easier. I used my multimeter to check the resistance of several terminals that go to the read portion of the head, but the values coming back all looked good. Just to be sure, I decided to try swapping the head over from the first DCC deck I bought. In most cases, you don't want to do this, and it's because every DCC head needs a different current level in order to operate properly, due to manufacturing tolerances. It's actually written on the ribbon cable from when it was built, and as part of the assembly process, the read-write board would be adjusted to match this value. But it really only applies to writing tapes and not so much reading them, so for testing purposes, you can get away with connecting a head to a board it didn't come with. And in my case, the other head produced the same results, so that meant my problem was definitely with the read-write board. The service manual for the DCC 900 was less helpful than I had hoped. After some brief guidance on disassembling the unit and entering service mode, it went straight to circuit diagrams with minimal troubleshooting information. Thankfully, the manual for the Technics RS-DC10 was much more useful. It and the DCC 900 were basically the same product because Technics' parent company Matsushita had partnered with Philips during the development of DCC. In fact, the DCC 900 was made in Japan, likely right alongside its Technics counterpart. The manual listed how measurements could be taken from the read-write board to confirm it was working correctly. I soldered a few jumper wires to the relevant pins, then carefully set up my oscilloscope. First up was an analog cassette. With the tape stopped, the frequency of the signal was about right, but I should have seen an even waveform. What I got instead was a lot more choppy than what the manual showed it should be. And with the tape playing, I should have seen the waveform change, but it didn't. I tried again with a DCC tape, checking the digital clock and sync signals, but they were out of whack too. Sync looked about right, but the clock signal should have been a clean square wave and much more frequent. And on this deck, it wasn't. So I went back to inspecting everything I could on the read-write board. I checked for continuity on any trace, via, or solder joint that looked even remotely suspect. I managed to find one via that still worked but was coming back with inconsistent results. It's part of the circuitry that powers the read amplifier chip. I decided to bypass the via by soldering a bodge wire between the capacitor it went to and the pin on the ribbon cable connector it came from. And this definitely had an effect. When I tested an analog tape, I was finally getting some audio, but it was mostly on the right channel with a very low level on the left. I found one trimmer on the board that looked ugly, and even though it tested okay, I replaced it anyway. I even reflowed some of the nearby solder joints just for good measure. And though the schematics showed it was all part of the left audio channel, that didn't help. I even went as far as setting up the tape mechanism so I could access the back of it while it was hooked up to the deck. I played a tape and tried adjusting those trimmers, but I can never get the left audio level to change. And perhaps to no surprise, digital tapes still didn't play at all. And that brings us to now. Clearly the problem is with that read-write board, but I'm out of ideas. It's been cleaned multiple times, all new caps. I even went and tested that read amp chip for functionality, comparing it to the one in the first read-write board. There's still something wrong, but for the life of me, I can't find it. As you could probably imagine, I'm pretty frustrated with this whole thing, not just because the first deck effectively got ruined at the hands of the Postal Service, but also that the second deck has managed to get the better of me. I've spent dozens of hours on this, and as badly as I wanted this video to have a satisfying ending, I'm just done. The insult added to the injury is that this was also an expensive undertaking. DCC was around for only about 4 years, from 1992 to 96, and for a few reasons, it didn't sell terribly well. So remaining equipment and tapes are pretty limited and command high prices. I found a DCC 900 on eBay that sold for about $400 US and claimed to have been tested, and I feel sorry for the buyer because the feedback on the transaction revealed that it's got the same playback problems mine does. It's clear that every first generation DCC deck is going to have bad capacitors, but it's a gamble whether each one will even be repairable. And that even goes for the occasional new in-box 900s that show up and sell for $1,000. These capacitor failures are a function of time and not use. Why not buy a later model DCC deck with a different design that avoids the problem? Well, you could, but availability is going to dramatically vary based on where you live. Here in the US, I've seen very few DCC decks that aren't first-gen models. In other areas, the situation may be better, but prices will still be high from people trying to avoid the problems of a first-gen deck. Even the media isn't cheap. I picked up a 3-pack of blank DCC tapes for $50, and the 2 pre-recorded ones I bought set me back $40 each. Between both decks and the tapes, I'm almost $500 into this and have very little to show for it. A restored deck would have gone for maybe about that much, and if I knew how this video would have turned out, well, that's probably the way I would have gone. I'll admit I'm salty about my predicament, but honestly, I'm not trying to dunk on this format. DCC is pretty interesting and definitely deserves its place in history, but it's not for everyone. It's the kind of retro tech that you need to really commit to, both in time and money. And thank goodness there's an organization like the DCC Museum to help those who do want to get involved in the format. They've helped to preserve a lot of information, and I owe them a debt of gratitude, not just for helping evaluate the first deck that I picked up, but also all of the repair videos they've produced. They ended up being a very useful reference while I tried to fix the second deck. I've realized two things throughout all of this. First, easy fixes are going to become less and less common with retro tech, especially stuff from the 80s and 90s. What started out as supposedly a simple capacitor replacement, well, turned into a nightmare. Second, it pays to be picky about what retro tech you decide to get into. The rarity of something may make it appealing, but it's also a double-edged sword. You may have fewer options if something goes wrong. I hope my experience let you get an idea about one aspect of DCC without having to make the actual commitment and end up in the same situation. And who knows, perhaps in time I'll be able to give you another look at the format. One with a hopefully positive outcome. If you liked the video, I'd appreciate a thumbs up and be sure to subscribe. You can follow me on social media at thisdoesnotcomp, and as always, thanks for watching.